Let's take a look at exercise 19 from section 6.1. So we start with the matrix, and we are row reducing this matrix to get it in row echelon form. And we've been given two matrices that would result along this process that contain missing elements. We want to fill in the missing elements. So we notice that we've gotten in row 2 a 0 in column 1 of row 2. And so we would have used row 1 to do that, and we multiplied -2 times row 1, and we've added that to the original row 2 to get this new row 2. So let's look at these processes. So we're taking the row 1 column 1 element and multiplying it by -2. And then we're adding the original column 1 row 2 element to that. And so we're doing that for every element in row 1 with the original row 2 element. So that means to get the column 2 row 2 element in the new matrix, we're multiplying -2 times -2. This was the -2 was what was in row 1 column 2, and then we're going to add the -2 that was in row 2, and we're going to do that all the way across the line. So we're also going to multiply -2 by -3. So this is the third column element of row 1, and we're going to add to that the 3 that was in our original row 2. And then we're going to do -2 times -11, and we're going to add to that the 2 that was in our original row 2. All right, so we see that -2 times 1 is -2 plus 2 would give me 0. -2 times -2 is 4, plus -2 would give me 2. -2 times -3 is 6, plus 3 would give me 9. -2 times -11 is 22, plus 2 would give me 24. So these missing elements are 9 and 24. All right, now similarly, we want to find out how we get the missing elements in row 3. So we notice there's a 3 in the original row 3, a 1 in my row 1. Notice row 1 is the row that's not changing. So that's the row I have to use to change both row 2 and row 3. So I'm going to multiply -3 times row 1, and I'm going to add that to my original row 3. So we're going to follow a similar process. So -3 gets multiplied by the 1 that was originally in row 1. And then I add to that the 3 that was in my original row 3. -3 gets multiplied by the -2 that was in row 1 and added to the 1 that was in my original row 3. -3 gets multiplied by -3, and I add to that the 8 that was in my original row 3. -3 gets multiplied by -11, and I add to that the 22 that was in my original row 3. So I have -3 plus 3, which is where I get that 0 from. For column 2, I have 6 plus 1, which is where the 7 came from. In column 3, I have 9 plus 8, so that missing component would be a 17 in column 3 of row 3. And then I have negative 3 times negative 11, 33 plus 22, which gives me 55. And in that second matrix, in row 3, column 4, is a 55. And so I notice that in this third matrix, since the first components haven't changed, neither do the row column 1, column 2 components don't change in row 3, so neither do the column 3 and column 4 elements. Those remain as I found in the second matrix in this process. But I am making a change to column 3 and 4 in row 2. And notice this 1 in column 2 was obtained by dividing this element by 2. So every element in this row is divided by 2. So I get a 9/2. And I get a 24 divided by 2, which is 12. So I actually obtained this row here by taking the previous row 2 and dividing its components by 2. And that's how I'm obtaining this final row 2, is I divided the previous row 2 elements by 2.